7.5, continuing our review leading up to the wonderful final exam. Graphing. So the previous section was all about how to graph. We did a lot of things where we didn't graph, but we had to read information from a graph. So how can I do that? So looking at examples like this, you have to know all of these 6 parent functions, and if I graph one of them, you have to be able to tell me what the graph of that is, okay? So if I look at the example that you see here, this looks like the square root of x, but it looks like somebody moved it to the left 2 and down 1, 2, 3, down 3, and it looks like it's been reflected about the x-axis. So how do I do all of those things? F of x. The reflected is a negative sign. How do I move something to the left 2? That's plus 2, and how do I move it down 3? Okay, so f of x equal negative square root of x plus 2 minus 3. Okay, so you should be able to do that for all of the parent functions. What are other things we did? Looking at a graph and coming up with a domain, the range. Remember, the range is the only time you're ever permitted to travel on the y-axis. All the other intervals are on the x-axis. Okay, equations of asymptotes, lines that I do not cross. When does a function increase, decrease? Where is the function greater than or greater than equals 0, less than 0? What are the absolute and relative max and mins? What's the end behavior and limit notation? Can I do a vertical line test to see if it's a function? Horizontal line test to see if that function is 1-to-1 or not. Lots of things we were able to do quantitatively from a graph. So here's one where I give you a graph and ask you questions. This is a polynomial. Is this even or odd? You should be able to tell that is even because it goes up in both directions. Leading coefficient, it's going to have to be positive for that behavior to happen. What are the x-intercepts? Okay, I see those at -2, 0, at 0, 0, at 1, 0, and at 3, 0. Is there any multiplicity? The key to multiplicity is I do not cross the axis. So I don't see any of those guys because I'm crossing the axis at each of those 4 points. The limit notation. So what this means is as x goes to negative infinity, as you go to the left, where do your y values go? They go up. As you travel to the right on the x-axis, your y values go up as well. What is the y-intercept of this function? So this one's a little bit hard to see. Excuse me, no, it's not. Where do I cross the y-axis? I was looking for a moment. It looks like I'm crossing at 0, 0. Okay, that is my y-axis crossing. What are all the factors? So the factors are going to be x plus 2, x minus 1, x, and x minus 3. Okay, those are all the factors of this polynomial. What is the domain? This domain is negative infinity to infinity. What is the range? The lowest value I see here is -9. So the range is going to be -9 to infinity. Intervals where this function is less than or equal to 0. So that means where am I below the axis, okay? What are those intervals? These are x intervals. So this is the interval from -2 to 0. And because it's less than or equal to, those are brackets, and from 1 to 3. Now, where are intervals where it is strictly greater than 0? Where is this guy strictly greater than 0? That's happening right here, and right here. I see 3 intervals where that is happening. So it's happening from negative infinity to -2. It's happening in between 0 and 1. And it's happening from 3 to infinity. Absolute maximum, okay? If I look at this graph, so when I look at this graph, it is, when I look at this graph, it is continuing to go on. So absolute maximum, there's none, it goes to infinity. There is no absolute maximum. Absolute minimum. It looks like there are two of those. It looks like at negative 1.3, negative 9, and 2.3, negative 9. Those are absolute minimums. Relative maximum. So is there a maximum that is a relative maximum? Yes, it looks like at 0.5, 1.5 is a relative maximum. Is there a relative minimum? So if I look at this, I see I've already taken care of both minimums, and they're absolute minimums. So there's no relative minimum. Interval where this function is increasing, and then where is this function decreasing? Okay, so I want to do this off to the right so we can see this. Where is this function increase? And where does this function decrease? Okay, remember increase, as I travel from left to right, am I going up or am I going down? So it looks like for the intervals of increase, it looks like I start out decreasing. I increase in this section as I go from left to right, and in this section. Those are places where as I travel left to right, I'm increasing. So those intervals are on the x-axis. That first interval is from negative 1.3 over to 0.5. And the other interval is going to be from 2.3 to infinity. Those are the intervals of increase. Now the intervals of decrease. If I look at this, when I start from left to right, here's a decrease, then it increases, it decreases again. What are those two intervals on the x-axis? That first interval is from negative infinity over to negative 1.3, and the second interval is going to be from 0.5 to 2.3. Increase, decrease intervals are always in parentheses, okay? So that was what I asked for increase and decrease, and that's it. Is this function one-to-one? How do we test one-to-one? One-to-one, we draw a vertical line. If it crosses the graph more than one time, it is not one-to-one. So this function is not one-to-one. Okay, continuing on with graphical information. This polynomial, this has to be an odd polynomial. It goes up on one end and down on the other. This leading coefficient has to be negative by the shape of that graph. What are the x-intercepts? Negative 2, 0. Negative 0.5, 0. And 1, 0. Is there any multiplicity? No. Every one of those places I cross the axis. So there is no multiplicity. In behavior, as x goes to the left, my values go to positive infinity. As x goes to the right, my values go to negative infinity. The y-intercept looks like the point 0, 1. The factors are going to be x plus 2, x plus 1/2, and x minus 1. What's the domain of this function? It looks like negative infinity to infinity. The range of this function, same thing. It's going to be from negative infinity to infinity. Intervals where this function is strictly less than 0. Excuse me, or less than or equal to 0. So it's here and here. On the x-axis, that's the interval from negative 2 to negative 1/2. And the other interval is going to be from 1 to infinity. Intervals where this graph is strictly greater than 0. So that interval is going to be right here. And right here, I see two separate intervals. Negative infinity to negative 2 with the parentheses. And the next interval is negative 1/2 to 1. Absolute maximum. Okay, if you look at this one, this is going to go on forever, go down forever. There is no absolute maximum and minimum here. So in this case, absolute maximum, none. Absolute minimum, none. So every max and min I see is going to have to be a relative. So it looks like there's a relative max, a relative max at 0.36, 1.3. So relative max at 0.36, 1.3. And then the other place is that minimum has to be relative min, negative 1.3, negative 1.3. So negative 1.3, negative 1.3. Where is this thing increasing or decreasing? So let's come back up here and let me look at that over to the side. So intervals of increase or decrease. So as I travel from left to right, it is decreasing to there and is decreasing here. Those are two intervals. That's the interval, so decrease from negative infinity over to negative 1.3, and from 0.36 to infinity. Intervals of increase. Intervals of increase. It looks like as I travel from left to right, I'm only increasing over that one interval. That's the interval from negative 1.3 over to 0.36. Is this function one-to-one? So one-to-one means horizontal line test. So what that means is, can I draw a horizontal line and only hit the graph one time? When I draw a horizontal line, I hit the graph more than one time. This function is not one-to-one. Okay, so is this one-to-one? No. And when it's not one-to-one, the inverse is not a function. Will the inverse be a function? No, the inverse is not a function in this case. Now, let's look at some rational graphs. What are the domain restrictions? Okay. So in this case, the domain, I see asymptotes, so I see that x cannot be negative 1, and x cannot be 1, 2, 3, negative 3. Now, if I were to ask you for the domain, that means the domain is every number except those two numbers. So negative infinity to negative 3, negative 3 to negative 1, and negative 1 to infinity. That is the domain of this function. Okay, I can tell just by reading the graph. Equations of the asymptotes. There's an asymptote at x equal negative 3 and an asymptote at x equal negative 1. And again, so I got ahead of myself. The domain, I just found that right here by excluding those asymptotes. Okay. Now, it asks you a question here. If you restricted the domain to only be the numbers between negative 3 and negative 1, so that means if you only looked at this section, what would the range of this graph be? Well, if I only consider that, the range would be from what? 5.8 to infinity. And I can tell it's from that point, negative 1.8, 5.8 to infinity. Where's the function greater than 0? Okay, so again, it's just reading this graph. Places that I'm greater than 0, that's happening in this subpiece right here. And it looks like it's happening right here. So there are two places where I'm greater than 0. So that's happening from negative 3 to negative 1. And the last piece is happening from 1 to infinity. Where am I less than or equal to 0? So less than or equal to 0, that's happening right here and right here. Those are two intervals from negative infinity over to negative 3. And this has to be an open parentheses because it is an asymptote. And then also from negative 1 over to 1. X-intercept, it crosses the x-axis at 1, 0. Where is this thing decreasing? Okay, so it's asking you to fill in the blank. It is decreasing on the interval from negative infinity to where? So when I first see this graph, I see it decreasing from negative infinity to negative 3. Okay, so they're just filling in the blank here. From negative 1.8 to negative 1, what is the graph doing? So from negative 1.8, so negative 1.8 to 1, excuse me, negative 1, negative 1.8 to negative 1, this graph is increasing, okay? Negative 1.8 to negative 1, this thing is increasing. What's happening between negative 3 and negative 1.8? From negative 3 to negative 1.8, you can see this graph is decreasing. What's the value of f of negative 1? So look at my graph. F of negative 1 is right here. That's the asymptote. There is no value. So it is undefined. Relative minimum. Okay. Where are relative minimums in this graph? It looks like there's a relative minimum at negative 1.8, 5.8. Absolute minimum, there is no absolute minimum for this graph. You can see that it continues to go down to negative infinity. So continuing on, we have a polynomial here. This guy, I can tell it's an odd degree. It's a positive coefficient. It has x-intercepts at negative 1, 0. And also at 1, 0. It does not cross the axis at 1, so I know there's a multiplicity of 2 at x equal 1. Now, in behavior, as I go to the left, it goes to negative infinity. As I go to the right, it goes to positive infinity. What is the y-intercept? The y-intercept, they tell me here, is 0, 2. What are the factors? Okay, so the factors are going to be x minus 1, x plus 1, and I know there's a multiplicity of 2 at this particular one, okay, at x equal 1. So those are my factors. This domain is negative infinity to infinity. This range, same thing, negative infinity to infinity. Where is this function less than 0? That's negative infinity to negative 1. Where is this function greater than or equal to 0? That looks like from negative 1 to 1 and from 1 to infinity, okay? You see that those could be combined into one interval, the interval from negative 1 to infinity. So absolute maximum, if you look at this graph, there is no absolute max or absolute min to this graph. So absolute maximum, none, absolute minimum, none. So any max or min has to be relative. So there's a relative min at 1, 0. So relative min at 1, 0. And it looks like there's a relative max. There's a relative max at negative 0.33, 2.37. Negative 0.33, 2.37. Where is this function increasing or decreasing? So it looks like it increases as I start from left to right, all the way from negative infinity to negative 0.33. So increase, so it's here and here. So negative infinity to negative 0.33. So increase, negative infinity to negative 0.33. And then the other interval of increase is going to be from 1 to infinity. And where is this thing? That's my increase, okay? Where is it decreasing? So this guy is decreasing on this interval from right here. That's negative 0.33 to 1. Negative 0.33 to 1. So that is my decrease, and I got them backward. Give the exact equation of this polynomial, okay? So I know that this polynomial has to be f of x equals some number times x plus 1, x minus 1. And we know that the x plus 1 is squared, okay? So I know that that's what it has, excuse me, there's a, got that backwards. The double root is at x equal 1. So the squared term is going to be this one, okay? Now, what else do I know? I need another point in order to get that. It goes through the point 0, 2, okay? So you know that it goes through the point 0, 2. So you know that f of 0 equal 2. So in order to do this, what is f of 0 here? So f of 0 is you're going to have 2 is equal to a. When you plug in a 0 there, solving this for a, you get 2 is equal to a, and that's it. So your exact equation, this is f of x equal to x plus 1, x minus 1 squared. Is this function one-to-one? And you should be able to tell no. When you draw a horizontal line, it crosses more than once. So this is not a one-to-one function. So information from a graph. Looking at this, what's the domain of this? This is negative infinity to infinity. What is the range? That looks like negative infinity all the way up to the number 4. Absolute maximum. There is an absolute maximum of this graph at 1, 2, 3, the 0.34. Absolute minimum. There's not one. Intervals of increase. This function increases from negative infinity all the way over to 3. Where does it decrease? It decreases from 3 to infinity. Where is this thing less than or equal to 0? It is less than or equal to 0 from negative infinity over to what? Negative 1. And from, what is it, 5, 6, 7 to infinity. Where is it greater than 0? This function is greater than 0 from negative 1 to 7. Get the exact equation of this function. This is based on the absolute value of x. It's been reflected, so this is f of x equal negative absolute value. It looks like it has moved 3 to the right. It's moved 3 to the right, and it's moved up 4. So that's the exact equation of this function. Is this function one-to-one? No, you can draw a horizontal line and hit it both places. So it is not one-to-one. Its inverse will not be a function. So is this a function? Yes. Is it one-to-one? No. Is this a function? Yes. Is it one-to-one? Yes. Is this a function? It fails the vertical line test. No, it is not a function. Is this one-to-one? Well, no, it cannot be. Is this a function? Yes. Is it one-to-one? No. And that's it for reading information from graphs. So guys, there was a lot of information in there packed into what I can ask you about those graphs. So be very solid about those intervals and increase and decrease and max and min and domain and range.